An Anova test is a way to find out if survey or experiment results are significant. In other words, we can say that they help you to figure out if you need to reject the null hypothesis or accept the alternate hypothesis. So the topics that we will be covering in this today are as follows. Introduction to Anova, definition, variations of Anova, test of Anova, assumptions of Anova, and types of Anova. Now, as we see that the test of significance, or the t-test, is used to compute the mean value of two samples. Again, we also need to understand the difference in the mean of more than two samples or the populations cannot be compared by the same method. So, instead, we can use a statistical technique to compare the means of variations of more than two samples or a population, which is also known as analysis of variance, which means Anova. Now, the concept of Anova or analysis of variance was introduced by R.A. Fisher. Anova is based on two types of variations. One is variation existing within the sample, and the other one is variation existing between samples. And we will discuss about it further. So what do we learn about Anova till now? Anova means analysis of variance. So that is a statistical test used to analyze whether or not the means of several groups are equal. The ratio of these two variations is an indication of sample difference. Therefore, Anova helps in estimating whether more variations exist among the group mean or within the groups. As I said, they help you to figure out if you need to reject the null hypothesis or accept the alternate hypothesis. Analysis of variance is a synthesis of several ideas. It is used for multipurpose. As a consequence, it is difficult to define Anova concisely or precisely. Now, for example, we can use this Anova to compare the effectiveness of two or more drugs in controlling or curing a particular disease. So there are two types, one-way Anova, and the graph looks like this, where there is a comparison of two drugs with a control, and two-way Anova, the graphs looks like this, where there is a comparison of control, drug A, drug B among each other. Now next comes as a variations of Anova. So Anova, as I said, it is analysis of variance and is used when given samples are not corrected. Next is ANCOVA, analysis of covariance, and is used when group to be compared are corrected. Two-way Anova, two-way Anova analysis of variance is used when there are dependent variables. The next one is MANOVA. Multivariate analysis of variance is used when there are more than two dependent variables. Now, there are various assumptions of Anova. Anova is based on following assumptions. Anova required random sampling. The items of analysis of variance should be independent to each other or mutually exclusive. Equality or homogeneity of the variance in a group of sample is important. The residual component should be normally distributed. The variables of interest for each population or group has a normal probability distribution. The variance associated with the variable of interest must be the same for each population or for each group of data. Analysis of variance is also used for two different purposes. First, to ensure and test hypotheses about population variance. Second, to estimate and test hypotheses about population means. Coming to test of Anova. For performing the test of analysis of variance, following statistical steps are carried out. For example, sum of squares. So it's computed as a sum of square of deviation of the values for mean of the sample. It means it is denoted somewhat like this, where SS represents the sum of square, X dash represents the mean of sample, X represents the value of variables, and represents the total number of observation. So the next one which comes here is the mean square. So is the mean of all sum of squares. It is obtained by dividing SS, which is sum of squares, with the appropriate degree of freedom. So the formula looks like this. Now moving on to the types of ANOVA that we have already discussed. It's an observation of analysis of variance are classified according to one factor analysis or two criteria into two groups. So if we talk about the first group is the one-way analysis of variance. It's the simplest type of analysis of variance, also known as one-way analysis of variance. In one-way ANOVA, only one source of variations or factor is investigated, but investigations are carried out in 3 or more samples simultaneously. ANOVA is used to test the null hypothesis that 3 or more treatments are equally effective. For example, we can use it to compare the effectiveness of 2 or more drugs in controlling or curing a particular disease, to analyze the impact of iron intake in the antenatal mothers in 4 or 5 villages, or the effect of the applications of 2 or more types of fertilizer on the yield of several nearby fields. The next one is the two-way analysis of variance. In two-way ANOVA, impact of two different factors on the variations in a specific variable is tested. For example, effect of sex and age on variations in height in population of students from different classes, effect of literacy level of mother and socioeconomic status of family on the academic performance of the children, and productivity of several nearby fields influenced by seed variations and types of manure use. So if we see in this case, there are different variables involved. So I hope you could understand this video. Thanks for watching.